Hello everyone. Today we are going to explore Creo Parametric 5.0. I am Vikram and I will be taking you through the various details available in this particular software. So once you open Creo 5.0, you will find this particular window will pop up as a part of basic interface to access this particular software. In the top side or the toolbar, you will see the various options given for exploring this particular software. So you will see the open option, which can also be accessed through Ctrl plus O key. So once you open, it will ask about the location from where we need to open the file. So currently the location which is set up here is this particular location, and currently we don't have any file here. So that's why we are not able to open any Creo file here. Now another thing which we need to remember is, while opening the file, we need to choose a appropriate file format here. So let's assume if I choose all file options, then ideally it should list down all type of files which are supposed to be available in this particular folder. And if you are initially or upfront aware about the file, the type of file, let's say .prt, which is the part file designation for the Creo 5.0. Similarly, if it is assembly, then it would be .asm file. Likewise, there are different file formats available and which are associated with the different kind of modeling, the different kind of sketching, and so on. So this is how we can open the new file in the Creo. So this is just for example. However, going forward, we will discuss and explore this option in detail. Coming to the second option, the select working directory. So in this particular option, you can select a directory from your system wherever you wanted to work in a Creo. So let's say I wanted to work in a Creo, so that I can create a new folder in the same directory, and I can make a or select that particular directory for future work. And after selecting the directory, we need to just say OK and we are done. So this is about the working directory in which we can do the further work. The another option we have is erase not displayed. So this particular erase not displayed usually help us to remove all the objects which are not available in this particular window or in this session. And currently if I click here, you see there are no part files or no objects are available, hence we can't see anything. However, let's assume we were working on a couple of components before, then we would have found out that it would provide the big list of the working files which we can remove and start working on the new file. So the another option is model display. In the model display, we can set up a various options like working environment, let's say. So in the working environment, if you see there is a working directory. Then in working directory, there are different options, show user help prompts on pointer, sound bell for prompts and messages. So let's say if there are certain messages here, so all the objects in session are currently being displayed, no object will be erased. So likewise, messages or the commands or the directions would be provided, and there would be a sound bell associated with those messages and commands. Then save display with model. So likewise, there will be multiple options. Similarly, there will be a model checking settings. So you can define a model checking settings here, okay, which we will discuss in detail, which is the specific, let's say, async dash port. So this is a communication port between the model check and Pro engineer. Okay, we will discuss on this in detail as and when this particular options to be used in the assignment. So I will, as of now, I will close this. Again, I will go to the model display. Then the more important options which are to be used in the Creo are sketching, then model display during the modeling, sketching, model display, and the assembly. Okay, so these are the more often used options in the Creo. So in the model display, again there is a model orientation. So what kind of default model orientation you want, whether it is isometric, trimetric, or user defined. So currently we have chosen trimetric as a default orientation. Once you prepare a model and put into the default orientation, there are multiple settings associated with the model display and while reorienting the model. So currently we have checked the orientation center, it will show. So when you rotate the model, we will be able to see the orientation center during the spinning, spinning of the model. Then the datums, then fast hidden lines removal, show surface mesh, show seal houghty edges, use time to draw frames, animations, and so on. So we will explore these options during working on one of the either sketching assignment or modeling or assembly assignment. Then there are again some of the default display settings which are provided by the software, and we can make use of these settings as and when required during the modeling. Then there is a sketcher. So in the sketcher you can see again there are the display settings. Then there are various sketching options and assumptions provided in the model. So we have checked, or the software has by default given all these options, which are like, you can see, lining up horizontally, then vertically. Okay, what it means is when you try to draw a line, either horizontal or vertical line, it will by default consider it to be a perfect horizontal or perfect vertical lines. Similarly, other options like parallel lines, perpendicular lines, the lines of having equal length, the corners of having equal radii, then collinearity of the two lines, the symmetricity about the axis, midpoints, and the tangent. So the circle is tangent to the line. Okay. So these are some of the sketcher constraints or assumptions which are considered by the software as the default options. Okay, and remaining things more of like a default options given by the software. Now coming to the assembly, then in the assembly, as you know, we need to have the two or more components which needs to be assembled together in the Creo. So for that, let's say you started with the basic first component, then you need to have an external component with the certain reference associated with that external component, so that you can bring that external component for assembly with your existing component. So for that you have a option called as the external component permitted for reference creation. So you can see all the components which you are inputting from the external directories, chosen as a by default option. Then likewise there are by default options given like placement reference to backup. So you can place a reference and which will be considered as a backup. So all these options, we will consider, we will use it during the assembly process. And the option which is widely used or which is of more important, that I will highlight or connect back with this particular settings. So we will choose by default as of now. Okay, and then we will start exploring the other tabs available. So I will say yes as of now. Okay. So this is about the model display. Then system appearances, again we'll go to the selection, model display. In model display we already seen different options. Then in sketcher, okay, I think we have already explored this. We can just come out of this particular option. Now on the left hand side you will see the folder browser, okay, and another thing, there is a folder tree. So currently we are into the my document folder, right, where we have set up the directory. So you can just minimize this. In the folder browser you can go to the desktop, okay, you can go to the any other location in session, let's say, and you can explore the files of your importance or which you have already created earlier. Another important option is model tree. Now this model tree is grayed out currently because we haven't built anything. We are just starting from the scratch, right? And then there is a favorite. So in the favorites, this particular option will be used when you create certain files, certain sketches or certain assemblies as a favorite, which you would be using more frequently from favorite list, and that is how it is treated as a favorite. So this is the home portion of the software. Then let's go to the file and understand what all things are given here. So we have a new tab here which is basically calling out new layout, the sketch, the part, assembly, manufacturing, drawing, format, notebook. So these are the different types of the options available in Creo, and which you can learn and work around it in a upcoming sessions. And the subtype is whether it is a solid modeling, whether it is a sheet metal modeling, whether it is a bulk modeling. And this is a by default file name would be given by the Creo PRT0001. Here we can enter the name of our file which we are going to model as a part, okay, and we can store at a desired location. Now in this there is a checkpoint called a use default template. So let's uncheck it, okay, and create a new part file, okay. Then it will ask for a templates, okay. Now there are multiple templates in the Creo which are associated with different unit system. Now let's say if I go to the inch, pound, part, solid, okay. So this is one kind of solid modeling template which is available in the part modeling type, and the unit of that template would be in inch, pound system, okay. So when you uncheck that particular box, you will be directed to assess the template of your choice or of your interest in the given modeling setup. Now in the template you can have a template stored in one location. All the templates which are being used in your organization or in your academic system, those templates can be accessed by this particular option. So currently we haven't stored any template here in the directory, that's why it is not highlighting any details. So let me choose any default template here. So let me go to the Newton second, okay, and then it will open a new file or the window, okay, which is being used to create a new part whose name we have given as PRT0001.prt, right, and which is part of a solid modeling now. So this is what window would be highlighted once you open the tab in the software. So we were in the file and we had just opened the new modeling or creating new model here. So this was the basic start of the modeling process, and once you open, this is what you will find. Let me again go back to the original file now. So I will just close it for time being. Okay. So we were in the file. So this is what new file creation we have seen. In the subsequent session, we will explore more on this particular model creation. Then second one is open, which we already discussed. You can open a new file from a given location, from a identified location. Then manage file. So in the manage file, you can rename the current object and the sub object. So you have a rename option over here. We can delete the old versions. Okay. So in the Creo, one of the important point you have to remember is, even if you are working on the same file, it will keep on creating the latest versions of a given object or of a given part, and it will assign the highest version number to that particular object or that particular file. And because of that, the size of the file will keep on increasing. Let's say if you are working on one particular model, which is of like a very long duration and very complicated model, it will have number of files created and associated with the version number every time you save that particular file, and that is the reason the file size becomes bigger and bigger. Now with the help of this particular option, you can delete all the older versions which you are not going to use in the future, and that way you can manage the file size. And if you wanted to delete all the versions, you can use this particular option. Now there is an instance accelerator option. So this particular option is being used to purge or update the instance or update the part file. What it will do is, it will always try to use the latest file which is being created in the folder and purge all the older files, and that way you will always ensure that we are working on the latest file. Okay, so this is what purge instance accelerator would be used. Then there is a manage session. So as we have seen, here is not displayed. So this is the option which will basically remove all the objects which are not which are either in the session or which were part of the earlier session. So I will just cancel it because we have part 001 already open. So we'll go to the manage session. Then there are other options. So working directory, object list. Okay. So in the object list we have a part 0001. There is no assembly, no drawing, no notebook, no section. So we have only part here. So likewise, the details of the session also can be listed here. Then in the help menu, we can go to the specific of parametric help, Creo parametric help. Then if you want to search any specific command or the utility, that also can be searched over here. Then if there is any specific query associated with the Creo, that can be filed using this particular option. And likewise, there are some resources available, online resources for which are the quick references for assessing the various details related to Creo, and some of the online references for installation, administration and configuration of the Creo. Then we'll go to the options. I think these options we have already explored. which we talked in this particular session. Okay, so this is all about the basic window which will pop up once you open the software Creo 5.0, Parametric 5.0. Thank you very much. Hello everyone. We will go to the modeling section, Okay, so let me create the part file or solid type. Instead of default template, we will use the Newton second part solid. Okay. Now in Creo, one of the important thing which you need to always keep watching is about this particular comment. Now what it says is, we have opened one file, okay, in Creo, and this is particular template we have been used while opening the file. Okay, so this is something. Here you will see all the comments or the directions, which you will be using during execution and working on the particular file. This is one important thing you need to be watchful on the various options. Now file already we have explored, okay, what all things are there. Now you can see there are some other options got highlighted. So save as, print. Okay, in the save as, you have a save a copy as an option. So you can copy the object in the active window. Now you have another important option which is save a backup. So by using this option, you will create a backup of your current work to some other folder or the current directory if you want. That is how save a backup option will work. Now mirror part. Now let's say you have a symmetric object and it is symmetric about certain axis. Then you need not to draw the complete object, or you need not to sketch or model work on a complete object. What you can do, you can have one common axis, and one of the side of that common axis you can just sketch and just mirror the part, with respect to that axis. So likewise you can save the mirror part directly. Then manage file, we have seen the prepare. Yeah, so this prepare is another important option which would be used almost in every files. Why? Because you can edit the model properties here. So you can define the materials, you can choose or change the unit system. Then you can also get to know about the mass properties. Okay, so that is why this particular option, the model properties, is very important, because you need to extract the masses, you need to define the materials, you need to also define the densities of the materials so that you can extract the accurate mass. So that is how the prepare section would work, and the model properties is one of the important distribution here. Then there is another option called as send, wherein you can send the file as an email with an attachment. You can also send email with a file as a link. Okay, that is how this particular option would be used. Manage session already we explored, help we already explored, and options I think we have already explored. So this is about the file. Now coming to the model, one of the important aspect is about the planes. So you see the planes are one of the key building blocks of the Creo software, and you can see there are 3 different planes highlighted. The F1 plane, I can highlight over here the datum plane. Then this is a vertical plane basically. This is another plane, F2 plane, which is a top plane and perpendicular to the earlier plane, right? And then there is a third plane which is a kind of horizontal plane and again normal to other two planes. So this is how the basic the three planar system been highlighted on the screen as a part of the default option. Now this particular planes, axis display, point display, coordinate system display and plane display, all these things would be selected from this particular option. Okay, so let's say I have removed the plane, default plane display now. Okay, similarly you can see the coordinate system here, part coordinate system definition, which consists of x, y, z axis. Now if I just remove this part coordinate system, then it would be just showing the default coordinate system which we seen as a part of the default option which is given while spinning the model or spinning the window. Let me select all the options, then system will show all the axes available in the part file or the assembly file or the sketcher file. It can display the points if we have created any points, coordinate system and the plane display. Let me just remove everything now as of now. Okay, or let me just put the planar display to start with. So this is the plane option. If you wanted to create any additional plane, then you can create the plane through this particular option. Similarly, the axis, points, coordinate systems and the sketching on any one of the planar reference can be done using these particular options. Okay. Apart from this, now you see there is a extrude option. So what happens in this extrude option? Let's say we have created one sketch, 2D sketch on a reference plane, and we have to create a object from that particular sketch. Then this particular extrude option will be used. Now let me just explain you how these two things will be used. Now let me just sketch something on this particular plane. So we have chosen a plane here. Okay, so you see in the message window it always shows that choose either reference such as surface, plane or edge to define view orientation. Let's say I have chosen this plane which is considered as a reference plane, and now I will say sketch. Now you see the reference lines will be created on that that reference plane wherein we can do some sketching operation. Now there is a option called a sketch view. Once you click on this particular option, what it does, it orients the sketching plane parallel to the screen. Now, and this is very convenient option, you know, when you wanted to start the sketching or when you wanted to start working on a particular plane. So you see this is what was the reference plane, and this is the reference line it has created when we given a command of sketching. Once you go in a sketch, then there will be a lot of option associated with the sketching commands. You know, you will find lot of options like circle, rectangles, lines, arc, ellipse, splines, fillet, chamfer, text, center lines, points, then coordinate systems and so on. So these all are the sketching tools or sketching commands which can be used to create a sketch on a given plane. Let's say I created a sketch, then I press the middle button in the mouse, and let's say I defined the diameter of this particular sketch to be or circle to be 50 mm. And with the middle button in the mouse you can zoom the object. So we define a sketch as a circle. We also given the dimension of that particular circle, and then just say OK. So now you have a circle which is sketched on a reference plane whose diameter is 50 mm. Now what I can do, I can use a extrude option. Now just rotate with the middle button of the mouse, just rotate the object, and you can see how this extrude of that circle can be done. With the help of the arrow, you can extrude the object either on back side of the reference plane or on the front side of the reference plane, and the amount of extrusion can be entered here. So let's say I wanted to extrude this circle by 100 mm to create one solid cylinder. So this is how this solid cylinder will look like. Okay, and then just say OK and see your solid cylinder is created. So that is how you see the datums. These are all the options related to the datum. Then the shapes. You can create various shapes, with the help of this particular option. And I just took an example of extrude, how we can create a 3D object of a desired shape with the help of one 2D sketch. That is how you will be able to blend or create a 3-dimensional objects from a 2-dimensional sketches. Again, there are different types. One is blend, and then there is a rotational blend. We will explore this, going forward, how these particular options can be used. Now coming to the engineering. Now in engineering there are various options, like let's say if you need to create a hole in the object, if you create the round on the edge of the cylinder, because in reality you cannot have such kind of sharp edges in any of the part, because it can hurt the user, or it can be creating some other problem like the singularity or the local load transfers. So for that you can have the round. So let me just give a round here, and let's say the diameter of that round is 2 mm, and you can just put the round in the body. Similarly, if you wanted to give the chamfer, you can give a chamfer here on this particular edge. Okay, the magnitude of the chamfer is 2 mm, and that can be set with the help of this particular options. There are different options. There is a dimension and the angle. Let's say you need a chamfer of 2 mm with an angle of 45 degrees. So let's say the angle of that chamfer is 45 degrees. So you can just give that chamfer here. Okay. Again, there are other options, like you can also give the draft. Okay. So that draft option we will see in the detail assignment. Then there is a shell. So it will be like hollow out the inside of a solid. Okay. So there will be a one hollow portion in a given solid. That is how shell will be created. And there is a rib, So basically we will create a rib on a with the help of a sketch which will be defined in a given path. So that is how it is called as the trajectory rib. That also we can explore in the detail modeling session. Then in editing there are another options like wrapping, removing the corner, splitting the surface, warping the surface, then collapsing, few features into single feature. Likewise the editing various options can be used. There is a pattern option. So the pattern option means, let's say in this particular surface you need to create a circumferential holes, for bolting the side plate on this surface. So let's say you need 12 such holes. threaded holes so that you can put the plate and then bolt it from the outside. So this pattern option will be very useful in these circumstances, wherein you need to repeat certain feature after certain angular distance, on all over the circumference. That is how patterning will be helpful. Then there is a projection option or project option, wherein we can project any sketch, any line, any chain of the lines, on a solid or non-solid surface, or also on the datums. Okay, that is how projection option will be used. Then there are some options related to the surface handling. So boundary shell, then filling, styling and freestyling. So these are more being used while working on the refining or editing the surface properties of an component or the 2D geometry. Then there is a model intent. So model intent are the component interfaces. So there are family tables. Then there is parameters. So we can we can define this body with the help of its diameter, the OD of the body, its length, and we can create different type of solid cylinders, by just entering or changing the various parameters. Similarly, the switching between the dimensions can be done. Then relations. So in the relation section, we can create the relation between multiple instances of an object. What I mean here is, let's say we need to define a gear tooth, on the OD of this particular body. Then we can define the formulas related to the involute gear tooth profile here, and just by modeling one tooth we can create multiple tooth profile all over the circumference of the body. This particular option will be very helpful while defining the geometry mathematically. So here you can import relations, external relations, or the equations, I would say. Then you can also export the relations. So let's say you have created one set of equations, or the set of details you have entered to create a tooth profile on this particular body. Those parameters can be exported to a different file for creating the similar pattern. So likewise, there are multiple options here which can be explored during the creation of the gear tooth profile, let's say on the 3D solid. So yeah, so these are some of the basic options available in the model tree. Then there is a regenerative option, so regenerate the body. Then regenerate manager, auto regenerate. So during the editing mode, we can keep on regenerating the model while we are working on very big files. Then there is another tab over here, user defined features. So UDF is something we can be used for creating some of the repetitively used features. Like let's say someone has to create the cylinders of different shapes, different dimensions repetitively, and which needs to be used for assembling purpose. So for that case, you can create the UDF feature, and you can just read that feature whenever we wanted to create this particular object for the subsequent assembly or during the modeling. Then copy geometry. is another option which we can use, to copy the some of the features from the geometry, or altogether geometry can be copied from the another model to start using that particular geometry in the current model. Shrink wrap, so it is more of like a representation of exterior shape, of the particular model. That is how this particular feature will be used. And then get the data, so we do have the import option, layout featuring, then independent geometry creation, and also the merging and inheritance. So this is not very widely used except the import option, so that's why we will not focus much on these things. Now this is all about the modeling portion of the software, and as you see, so we had these three datums here, right? So the moment you keep on working on the model, on the files, that system will start creating the model tree. So initially we had only these three datums and one coordinate system. Afterwards we created one sketch. You can see this sketch here, right? Then after sketch we had created, or we have performed one operation on that sketch, which was the extrude option, so which is also seen here. Then we put one round and then chamfer. So likewise the model tree will be started creating in the same order in which you perform the various operations, okay? And let's say we have to hide some of this operation, then you can just remove this insert arrow up, and then you can highlight the portion of the model which is of your interest. So I will just go to the back, so that we have a cylinder with chamfer on one end and round on another end. Thank you very much. Hello everyone. Go to the analysis. So in the analysis, the widely used options are basically the mass properties. You can extract the mass properties of this particular object. Now how you can do that? Let's say solid geometry, instead of default, you can use a coordinate system. So this particular coordinate system you can use. You can also define the density of your material, steel, aluminium, cast iron, and so on. So you can define the density here. Let's say 7.3 e raised to 5 e raised to minus 5 is the density, and based upon the kind of unit system we have used, it will give us the volume of this particular body, surface area, the density. We cannot just enter the density here. Why? Because that density was already taken from the default template which was being used. That's why it is taking density to be 1 ton per mm cube. Then it is throwing us the mass based upon this density, and then other mass properties also it is providing, like inertia tensors, Ixx, Ixy, Ixz, likewise up to Izz. Then inertia at the CG, so again inertia tensors with respect to CG. Then principal moment of inertia I1, I2, I3, and the rotation matrix, if we have done any rotation of the model, with respect to the reference coordinate system, which is default coordinate system. Rotation angle if any, and radius of gyration with respect to the principal axis. So this is how the mass properties, the inertia tensors with respect to by default coordinate system as well as the coordinate system from its CG, all will be given here, okay. Then we have a feature, so this is not, grayed out currently because we have not specifically defined any feature, which needs to be highlighted over here. So this is how the mass properties will be extracted, And one thing needs to be taken care is the density definition is very important, and based upon that density only you will get all the required details of the part. So let me just cancel this. So mass properties, then measure. In measure you can measure, let's say, diameter. So diameter 50 mm. Then you can measure the distance between these two surfaces. So what we have to do, you have to choose a surface, then press a control button, okay, and after pressing control button select another surface. It will give you the distance between two surfaces. So likewise there is area, volume, length, and another transformations, if any transformation with respect to the coordinate system. So this is about the measure. I will just close this. So these are the widely used commands, in the analysis, because we are not focusing on simulate analysis option, which basically performs structural or thermal analysis and help us to analyze the system for stresses as well as the temperature distribution across the body under given boundary conditions. So currently we are not focusing on that. So that's why these are the only two major buckets, where you can keep on working during the modeling, assembly and sketching. Thank you very much. Hello everyone. Coming to the annotation section. So in the annotation section, you can have different type of annotation, like how the part will be annotated with respect to the given frame of reference. So you see the flat to the screen, then front portion is to be annotated, so then top portion, then right portion, back portion, bottom, left. Likewise annotation planes will be created, and we can work on those annotation planes in some of the feature which we will see later. Then there are dimension, geometric tolerances, some of the features like datum feature symbol can be added on this surface. Similarly, few notes can be defined, for the particular surfaces, surface finish, then datum targets, symbols, and some other symbols like custom symbols from palette symbol gallery to be defined. Then there are again like planes, axes and sketches as we discussed earlier. So annotate is something to be used, more oftenly it will be used while creating the drawings and also some of the features, especially during animations. Then coming to the tools. So in the tool you can see model players. So in the model player we can have the various steps, by which the various feature will be created or which was created in the history for that particular part, that is how model player function will work. Then we will have the feature information, then model information and feature list. So let's say if we go to the model information, you will see the model information, model name, then the unit system, then we have three datums, datum plane, then there is one coordinate system, and it will also list down if there are any curves, protrusion, round, chamfer, those kind of details will be provided here. So you can see, you can just click and understand if there is any further information associated with that feature. So that is how the model information. Then let me just close this, okay. Then go to the model. So you see this model is being highlighted here. Then we were working in the tools earlier, So we were just trying to explore what are the model informations we had currently for a given set of model. Then there are some other options like reference viewers. So these are more of like investigative options, to understand the history of the model, to understand the details available in the model, and to know or to find out if any feature or any instance to be investigated. Then the model intent, this is more of like a component interface, to understand like the placement of the component, the name of the interface, the kind of template being used, and how that interface is placed, Then there are criteria and properties. This particular option is, very rarely used, so we are not going to explore much on this. Then again, publishing the geometry. So we can create a feature, which has a independent geometry, local geometry, which can be copied to other model to show the design intent. So let's say we had a hole at the center of this cylinder, and the similar cylinder with the hole, let's say we have to use it, or the feature of the hole, if we have to use it for other geometry during the modeling. So that can be published, that particular feature, and can be used for the other model. That is how it can be done. Then we have a family table. So family table, in that we can see currently we don't have any family table, but we can add the dimension or the feature parameter column to the table, So we can create a table. Let's say we can create a table like this, okay, and we can let me just cancel this. We can define the name, and we can also have various parameter definitions in the family table. So I will take you through the detailed family table creation and how to link with the given feature, during one of the course in the modeling session. So that is how it will be done. Then family table, then there will be parameters. So in the family table, we how the parameters will be used is, we will define the various parameters as a string type, and it will also have the associated values. Let's say the description is, in the description it was supposed to be diameter. So let's say the diameter was 100. That is the value of that particular feature. Okay. The model by, so let's say VD. So the model by whom, So likewise, we can define the various parameters, and those parameters to be used as a further refining tools, during the part modeling, as well as this is why also will be very helpful during the drawing preparation. So let me just say okay here. Then switching dimension, then defining the relation we already discussed. Then there are different utilities, UDF libraries, user defined features we can create, as we talked earlier, and those can be saved for as a library, and which we can use more often for performing certain operations. Then appearance, it is more of like the kind of appearance of the current system. Then there are some of the auxiliary applications, which we will discuss in one of the utility or one of the assignment. Then there are like some of the advanced options which are like AR related options. So spatial targets, then publishing model,
you can publish the augmented reality experience model for your CAD design. And some of the launching these AR models, to manage and share some of the experiences through AR. Honestly, we are not going to focus much on this, but if there is any specific requirement related to AR, that we can explore in the upcoming videos. Thank you very much.
Hello everyone. View, so this is more of like the various viewing options, for a given set of model. The more widely used options are like standard orientations, the previous orientation, then standard orientation, saved orientation if any. Let's say if we have any customized orientation which are saved, that can be used here. Then refit the model into the window, then zoom in if any section of the model to be zoomed, then zoom out, pan, similar to other softwares, you can pan the object in the window region wherever you want. Okay, so the pan zoom. Okay, you can also define the pan zoom, how you wanted to pan horizontally, vertically. Okay, the level of zooming, you can always define. So I will make it by default as of now, because I still have a liberty to zoom it wherever I want, and with the middle mouse button you can still zoom in and zoom out whatever you want. Then there are spinning option as well. You can spin as per the desired, and this currently we will keep as a default setting, so that we can make use of these features in better way during modeling. So this is about the orientation. Then appearances. So in appearances, we will just click on the object. Let's say we have to change the appearance of this object. Then we will click on the object. We will go to the appearance. Let's say we choose this particular reference color, and that way we can change the appearance of the complete body. So likewise, these appearances tools can be used from the gallery. Then zoom we have seen, orientation more of. Then model display. Then the another widely used portion is the section. So planar section. Let's say I have to take a section of this body, So what I can do, I choose a surface, and then I can define a distance at which, let's say I have to take a section at 30 mm from one of the surface. So that way the section of this body can be taken. So section is planar section. Then there can be a section in the x direction, section in y direction, z direction, offset section. Okay, so likewise we can use this particular feature to internally inspect the body and understand the section of the model. Manage views. So in the manage view, you can go to the view manager. There are different options in the view manager. Let's go to the section. So section XX section already we have taken. So let's go to the no section. You will be able to see the full body. Similarly, we can create a new section. Let's say in the X direction, give the name to be XX. So you see in the X direction of the body, section will be created. Just say OK, and this is the section XX. This is the section along the axis of the body, which we created earlier. You can, if you want, you can rename this. So this is along YY.
this is along x-axis, okay, x-axis, y-y. Likewise, you can make a sections in the body in a different direction and define them in the view manager, or you can see in the view manager. In view manager, you can see there are different options. So orientation option, then simple representation. These representations will be used during handling the bigger parts as well as bigger assemblies, and this will be also used while creating the drawings, of the sub assemblies or the few portions of the bigger assembly. So that is how these options will be used. Then there are appearances, the kind of appearances we wanted to use, then the layers, and then all together, all the options together. So likewise, we can use the viewing manager, to understand the various part of the model. Then display, how you would like to see or display the body, that can be seen. So let me go to the section, say no, let me close this. Then shade with edges, you can see the shading with the edges, then only shade, then no hidden, so it will show only the edges, then hidden lines, if there are any hidden lines in the model, that will be seen. Wireframe model, only wireframe will be seen. So let me go to the shading. Then there are planes, plane display, all the show options, similar to what we have seen here. Then activate the window, then close the window, current window. Likewise, that current window can be closed. Then go to the again file. So in current window, you can see the part 2 is being active, and if you close this particular active component will be closed or removed from the current session. So this is all about the viewing part of the window. Then one of the thing, layers. So these are the layers is another important section. I think I forgot to cover here. So in layers, you can have the different datum planes. You see, you will get the details about the datums. You see, then axis, curves, point, coordinate systems, then surfaces. So all the details related to the planes, axis, curve, point, coordinate system and surfaces are stored in the layers, and this will become very useful when you are going to work on very bigger assembly or the bigger components. This layering is very important. We will explore like how that can be used in the future. Thank you very much. Hello everyone. Now then there is a flexible modeling. So in flexible modeling, so this provides the quick options to modify or to transform the geometry. How I will tell you. Now let's say I have to offset this surface, quickly. Now how I can do it is I can go to the sketch, right? Then again create a circle and then modify that surface or extrude or remove some material from it as and when required. Now this flexible modeling or the transformative options, help us to offset certain surface very quickly. Let's say we have to offset this surface, this individual surface only by 10 mm. So we can directly offset that surface by 10 mm using this option. You can see it just transforms the surface from its initial position to next position. So initial end to end length was 100 mm, now it will become 110. So likewise this offset option will be utilized. So these options like move using a dragger, move by dimension, move using constraint. So you can move certain surface, certain feature in the object using these particular options. You can also do modify analytically, select a cylinder, torus or cone to modify. You can select certain object to modify it quickly, with the help of the surface. Then you can also mirror. So you can select a geometry or datum plane to mirror about. So as I mentioned earlier, for mirroring, you need to have the reference either plane or a axis about which you can mirror the object, which we can explore later. So likewise, you can edit the round chamfers. You can also make a flexible pattern, as I mentioned in the pattern making. You can also have the symmetricity in the body. You can attach, remove some of the features, or the surfaces from the model. So likewise, this is how the flexible modeling will be used. We will ensure to make use of these comments, in some of our modeling assignments. Then the last important options, or I would call it as a high-end options, which are given or added in the latest version of Creo, which consist of, it can provide us opportunity to start the welding application. Then it also help us to simulate the molding and casting, and it also help us to simulate some of the structural and thermal problems. It helps us to simulate the result, Let's say we have to see the animation of how this cylinder is behaving if it is fixed at one end and the load is applied on another end. Then how this body will deform. So that kind of simulation we will be able to see. Then mold analysis. So in the casting domain, when we pour the molten metal into the die, how that molten metal flows, in a given time duration, and how it solidifies. So that kind of simulation also can be performed. Then geometrical dimensioning and tolerancing advisor. So this is another high-end tool which help us to provide a direction about what kind of GD&T has to be defined or labeled on a given surface, given feature, so that it can be manufactured through the given manufacturing route, like it can be machining, casting, forging, cold forming, and so on. Then the generators and the rendering, we haven't explored so much, and probably this is not in the current scope, so we will not cover it. So coming to the modeling portion, as we were talking, so the modeling of a cylinder, which as a basic example we have studied today. In the next lecture, we will take one example and start modeling the 3D object with the multiple operations. We will try to make use of maximum tools from the toolbar, so that you will get more acquaintance to the various options available in the Creo. Thank you very much.